Okay, here's the next problem. So I have a wire, and it's a special massless wire, but it's 10 meters long and it has a tension holding it together of 30 newtons. Okay, so the tension on that side is 30 newtons, tension on this side is 30 newtons. And you could easily do this by like putting a pulley over here and put masses on the ends, and so you know the tension. Okay. But it doesn't matter. But then I take this 1 kilogram mass and I hang it in the middle. Well, the rope's going to go down, so it's going to look like this, like that. Now, if it's a massless rope, then these will be straight lines. But just imagine if the rope has mass, then it has to sag on its own. Even no matter how tight you get that, it will have to sag. Okay, but that's a much more complicated problem, so we won't worry about that right now. So we want to calculate. I want to calculate this distance. How far down it drops. We'll call that h. Okay. So let's first just look at the mass. Let's look at this point right here. That point right there, the change momentum is 0. So let's draw a force diagram for that. We have mg going down, right? The gravitational force from this mass, and then I have tension here and tension right there. And if it's in the middle, those should be the same magnitude and the same angle. So this is T1, T2, and this angle we'll call theta. And they're both at the same angle theta, both the same magnitude. So if I could find that angle, then I could use some geometry magic to find this drop. So I know that the following has to be true. The net force is 0 because everything's stationary. So that says T2 plus T1 plus mg equals 0. Now, let's just look at the y direction. In the y direction, I have a component of this tension plus a component of that tension minus gravity. So in the y direction, I have T2. Now, what's this component? That angle's theta. So this T2y is going to be T2 sine theta. And the same thing's for that one too, plus T1 sine theta minus mg equals 0. T1 and T2 are the same value. Okay, but I don't know theta and I don't know T1. But I can write this as 2t sine theta equals mg. But I don't know t and I can't solve. Okay, I want theta. Now let's look at the x direction. The following has to be true. I'll just leave this as t. T cosine theta. Did I make an unsolvable problem? T cosine theta equals t cosine theta. Sometimes this happens. Oh no, I didn't make it unsolvable. I said the tension was 30 newtons, and it stays 30 newtons. I did say that. So I don't need that. I just need that. I know t is 30. So sine of theta equals mg over 2t. So there's my sine of theta. Now I want to go back. If I look at this diagram, this is theta, so that is theta. So I have this like that. And I know this is going to be 5 meters to the halfway point. So I want to find h. So if that's 5 meters, this is going to be, let's call that x. And this is s. Then s is going to be equal to the square root of x squared plus h squared. And I know that the sine of theta is going to be equal to s over x. So I can do the following. I know x. I don't know s. I don't really care about s. But s equals x sine theta. And put that in up here. Rewrite it. I get x squared sine squared theta equals x squared plus h squared. So h squared equals minus sine theta squared minus 1 times x squared. So now I know x is 5. I know theta is that, so I can solve for h. I guess you want me to put the numbers in, don't you? Fine, I'll do it. Okay, so see theta, so t equals 30, m equals 1. Let's see, but t equals 30. G equals 9.8. So x equals 5. So h equals the square root of sine of theta. Oh, I didn't do that. Okay, let me put it over here. Arg. I don't have theta in. Important. Let's see if we can do this. Okay. Let's try it again. So h equals square root of sine of theta squared minus 1 times, oh, I didn't calculate theta. Okay. Oh, I don't need sine theta. I don't need sine. Sine theta is mg. Okay, so let's try this again. H equals square root of sine squared theta, which is going to be m squared. It's going to be times g divided by 2t all that squared minus 1 times x squared. Okay. Oh, and then I got to take the square root of all that. Nope. I missed it. Okay, so invalid syntax. Arg. Okay, square root that. Am I missing that thing? Oh, I can't do it. Okay, made a mistake somewhere. 1, 2, 3, 1, 2, 3. I guess I need another parenthesis over here. I'm just wasting time here. Alright, let's try that. Okay, no, I messed up. Okay, well you plug in the numbers.